So today we are going to start with the second class. This is our second class in circle, and this class has been divided into two sessions. This is your part 1 and part 2 will come after this. So today we are going to complete intercepts made by circles, power of a point, and length of tangent. This will be our topics that I am going to cover in this lecture. In the next part of this class, we will complete with equation of various tangents and direct a circle, right? So this class is divided into two sessions. Today is our first session, which we are going to complete the intercepts by circles, power of a point, and length of tangent. And in the next part, we are going to cover equation of various tangents and direct a circle, right? So let's start by recapping our class 1 lecture. I think all of you have already seen the first video of this circle lecture. So there we have all done with different forms of circles. The first one, which was very, very popular and very important, which is your center radius form. That is, if you know the center of any circle and if you know the radius, we can find out its equation. Is it clear? Right? So what was the form? Suppose if we have a circle, let me just change the color of the pen. If we have a circle and if we know its center, let us say the center be at alpha comma beta, and let us say the radius be r. Let us say the radius be r. Then the equation of this circle will be x minus alpha whole square plus y minus beta whole square equals to r square. This is what is called your center radius form. This we have already done in our first lecture. Next is, what is your standard form? The standard form is x square plus y square is equals to r square. It means that the center of that circle is at 0, 0 and radius is r units. Okay. This is called your standard form. Next, we are coming for general equation of a circle from second degree equation. We all know that a general second degree equation looks like this. Now, this equation will represent, this general second degree equation will represent a circle when the coefficient of x square and coefficient of y square, they are same, and there is no xy containing term, that is your h will be equals to 0. Then this will represent the equation of a circle, and the equation of the circle looks like this. This is what is also called the general form of a circle, and whose center is at minus g comma minus f, and its radius is root over g square plus f square minus c. Okay. Then we are coming for concentric circles. What do you mean by concentric circles? Concentric circles are those circles whose centers are same. If the center of circles are same, only the radius differs, then we call that circles are concentric circles. Center same. So for any equation, let us say this is the equation of a circle. Now any concentric circle to this circle is everything will remain same. Everything remains same. Only this constant term will differ. Because as we all know that concentric circles, they are having their centers equal. Centers same. Only the radius differs. That is why I have added a constant lambda over here. This I have all explained in the first lecture. Then it is diametric form of circles. Diametric form of circles is that if we know the extremities of the diameter, they are x1, y1 and x2, y2, then the equation is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. Clear? So this is what is called your diametric form of a circle. Then the last part that we have done there is what called your parametric equation of a circle. We know that for a circle, standard circle, which is x square plus y square is a square, the parametric form is x equals to a cos theta and y is equals to a sin theta. This I have already explained. Moreover, if we are having a circle in the center radius form like this, then its parametric form will be x minus alpha is a cos theta implies x is alpha plus a cos theta, and y minus beta is a sin theta, that implies y is equals to beta plus a sin theta. So this is the parametric equation of the circle. Is it clear now? So this we have already done in our lecture 1. Those who have not seen, they can visit the playlist and they can see that lecture. It will be, if you see that lecture before this, it will be helpful for you because I'm not going to repeat the same thing here. Okay, so let us now start with the intercepts made by circles. Intercepts made by circles. What do you mean by that? Let us say let me draw the circle first. Now, so this is a circle which is intersecting the x-axis, which is intersecting the x-axis. So what we want to find here, let us say the equation of the circle be the general equation. Okay. Now we want to find out the intercepted length. That is, we want to find out this length. What will be this length? The circle is intercept. The circle has intercepted the x-axis. Now we want to find out the length of the intercepted portion. Let us say the coordinate of this point be x1, 0 and this point be x2, 0. So basically we want to find out what is our x2 minus x1. Right? So to find out this, we should know the points. So for that, to know these points, we have to solve the equation of this circle and the x-axis. Equation of x-axis is y equals to 0. So now if I solve y equals to 0 and the equation of the circle, what we are going to have? We are going to have a quadratic equation in x. Right? So this equation, it will have two roots. One is x1, another one is x2. So your x1 plus x2, this will be minus 2g. And x1, x2 will be c, sum of two roots and product of two roots. Now we want to find out x2 minus x1. So x2 minus x1 whole square can be written as x2 plus x1 whole square minus 4 x1 x2. So let me just replace that. x1 plus x2 is minus 2g, so it will be 4g squared minus 4c. So x2 minus x1 will give us 2 root over g square minus c. So the intercepted portion on the x-axis by the circle this is 2 root over g square minus c. Now similarly, if we draw the same thing when the circle is intercepting the y-axis, in that case, the intercepted portion that is this length, if this point is 0 comma y1 and this point is 0 comma y2, then this intercepted length will be 2 root over f square minus c. How I got it? Doing exactly the same way as I have done here. Here I have solved the x-axis with the curve. In this case, we will solve the y-axis with the curve. The equation of y-axis is x equals to 0. So put it and find out the distance between AB. Is it clear? The same way as I have done right now. So two things we have to remember here. That the intercepted portion on the x-axis is 2 root over g square minus c. This you have to remember. As well as the intercepted portion on the y-axis is 2 root over f square minus c. At the same time, you must know the way I am solving to get this answer. Getting my point? Because in some problems, it will be needed the method that I have done here. Okay, so the method, how I'm doing it, is also very important. Now, a very interesting thing is coming, is that we got there is a circle. Now, let us say it is intersecting the x-axis. Okay. Now we got this thing as this is let us say just one second. This point, let us say this is x1 comma 0 and this is x2 comma 0. Correct. So this intercepted length is what? Is basically 2 root over g square minus c. And the equation of the circle is the general form. Okay. Now, one thing you must see, that as g square minus c is under the root sign, so naturally 3 cases will come. 3 cases will come. What are they? One is when g square minus c is greater than 0, when g square minus c is equals to 0, and when g square minus c is less than 0. Is it clear? Now, when g square minus c is greater than 0, then we are confirmed that there will be an intercepted length. That is, the circle has intersected the x-axis. Okay? If g square minus c becomes 0, then what happened? The intercepted length becomes 0. It means the circle is only touching the x-axis. Try to understand it. In that case, your circle is simply touching the x-axis, or you can say the x-axis will become the tangent to the circle. When this relation holds true, when you find that your g square minus c is equals to 0. And there will be an intercepted length when g square minus c is greater than 0. But if g square minus c is less than 0, in that case what will happen? It is not going to touch the x-axis, nor it will intersect, nor it will touch. Getting my point? This is that case. Neither it is intersecting the x-axis, nor it is touching the x-axis. In that case, your g square minus c will be less than 0. Is it clear to everyone? Absolutely. Okay. So remember three things. When g square minus c is greater than 0, it is intersecting the x-axis. If g square minus c is equals to 0, it is touching the x-axis. That is, your x-axis becomes tangent to this circle. And if g square minus c is less than 0, it means neither it is intersecting the x-axis nor it is touching the x-axis. Is it clear? So same thing with your y-intercept. Your y-intercept, what we have learned? It is 2 root over f square minus c. In this case also, we are getting three conditions. The first condition is that when f square minus c is greater than 0. What do you mean by that? It is intersecting the y-axis. It is intersecting the y-axis. Let me just draw the diagram. This is the case. Okay. In this case, what happened? The circle is intersecting the y-axis. What is the condition? The condition is f square minus c is greater than 0. Now the second case is f square minus c is equals to 0. It means what? It is simply touching the x-axis. I'm sorry, y-axis. It is simply touching the y-axis. It is simply touching the y-axis. So what is the condition here? The condition here is f square minus c is equals to 0. And what about this? F square minus c is greater than 0. Now, the third case is when f square minus c is less than 0. It means what? It means that it is not touching the y-axis, nor it is intersecting. It is neither intersecting nor touching the y-axis. It is something like this. Is it clear? What is the condition? F square minus c is less than 0. Is it clear to all? So when f square minus c is less than 0, we will say that the circle is neither intersecting the y-axis nor it is touching the y-axis. Clear? So now a very interesting thing is that if we combine those things, we can get different forms of circle, different condition of the circle touching or intersecting the x and y axis. Like if I say that your g square minus c is greater than 0, but f square minus c is equals to 0. What do you mean by that? G square minus c is greater than 0 means it is intersecting the x-axis. F square minus c is equals to 0 means what? It is touching the y-axis. So how your circle will look like in that case? The circle will look something like this. It is intersecting the x-axis and it is touching the y-axis. Are you getting my point? So for this circle, for this condition of the circle, the conditions are g square minus c is greater than 0 and f square minus c is equals to 0. That's it. Now I can take another condition also. Let me just move this thing a little bit so that we can get space to draw. Okay. So let me just draw in this way. Now, tell me one thing. What is the condition? What is the condition that the circle is going to touch both the x and y axis? Tell me. This is very important because this is frequently needed in our problem. What will be the condition? In this case, it is touching the x-axis. It means what? G square minus c is equals to 0. At the same time, it is touching the y-axis. It means what? Your f square minus c is also equals to 0. Tell me yes or no. So these are the conditions for which the circle is going to touch the x and the y-axis. Now, I'm drawing this circle in the first quadrant. It doesn't mean that it will touch always, the circle will lie in the first quadrant. No, it can be in the second quadrant. It can be in the third quadrant. It can be in the fourth quadrant. Getting my point? But the condition is that in every time, in every case, it will be touching the x-axis as well as it is touching the y-axis. So condition is what? G square minus c is equals to 0 and f square minus c is equals to 0. So very interesting thing is that in this case, particularly in this case, if the center is at r comma r, what do you mean by that? From the origin, you move this distance r and then you move this distance r. So the radius of this circle is r, but the center can be of plus minus r comma plus minus r. Why it is so? Because as I told you right now, the circle can be in the first quadrant, it can be in the second, third or fourth quadrant. So when it is in the first quadrant, we will take the center as r comma r. When it is the second quadrant, we will take the center as minus r comma r. In the third quadrant, it will be minus r comma minus r. And in the fourth quadrant, it will be r comma minus r. That's it. Okay? And when it is touching both the axes, the radius r will be the abscissa or ordinate of the center. Because here, when it is touching both the axes, the coordinate of the center is r comma r. And in that case, your radius will be also equals to r. Is it clear to all of you? Is this clear? So it's pretty simple. Simply remember that the intercepted portion on the x-axis is 2 root over g square minus c. And on the y-axis is 2 root over f square minus c. And if g square minus c is greater than 0, it is intersecting the x-axis. If it is equals to 0, it is touching the x-axis. And if g square minus c is less than 0, it is not touching, neither intersecting the x-axis. Same thing with the y-intercept also. So simply remember this, and simply by permuting these 6 conditions, you will get different position of the circle. Okay? So I have simply summarized this thing, whatever I have said so far, that your x-intercept is 2 root over g square minus c, as I told you. Y-intercept is given. Exactly the same thing I have written. When g square minus c is greater than 0, it is intersecting the x-axis at 2 different points. When it is equals to 0, it is touching the x-axis. And when it is less than 0, there is no x-intercept. Similarly, with the y-axis, f square minus c greater than 0, touching at 2 different points. Equals to 0, touching the y-axis means your y-axis now becomes tangent to the circle. And f square minus c is less than 0, there is non-real y-intercept. Okay? So all of you, I'm telling you, after the class, you can download this class PDF from the link given in the description box. Okay, so now, very important note. When the circle touches the x-axis, now tell me one thing. The equation of the circle for all these 3 cases, I am taking this one, the general equation. The general form I have taken. Now, what is its radius? Its radius is root over of g square plus f square minus c. Now, for this condition, for this case, The circle is simply touching the x-axis. It means what? Your g square minus c is equals to 0 implies your g square is equals to c. So what will be its radius? What will be its radius? Radius is root over g square plus f square minus c. So g square minus c is 0, so it becomes root over of f square. And that gives us nothing but mod of f. Is it clear? So for the circle which is touching the x-axis, your radius is modulus of f. Clear? When the circle is touching the y-axis, then your f square minus c, this is the condition, just now we have learned. F square minus c will be equals to 0. So in that case, what will be your radius? Root over of g square plus f square minus c, but f square minus c is 0, that gives us root over of g square, and which gives us nothing but mod of g. Is it clear? So we got mod of g is the radius of the circle when it is touching the y-axis. In all these cases, your center is minus g comma minus f. In all these cases, the center is at minus g comma minus f. Now, in this case, what happens? In this case, what happens? In the third case, when it is touching both the x and y axis, in that case, we have g square is equals to c. At the same time, f square equals to c. Tell me yes or no. So what will be its radius? Its radius will be root over of g square plus f square minus c. So if I take g square equals to c, we are getting the radius is root over of f square, which gives us mod of f. And if we take f square equals to c, then we are getting our radius as root over of f square minus c is 0. So it is coming to root over of g square, which gives us mod of g. Therefore, your mod of g and mod of a, they are all same. Is it clear? That is, the center will be what? It will be minus g comma minus g, or you can write this thing as minus f comma minus f. They are all same. Is it clear? So if we consider for our simplicity, let us say this is nothing but our R. So the center will be, it can be in the first, this condition is satisfied when the circle is in the first, second, third or fourth quadrant. I have already mentioned this. Therefore, your center will be, if this is equals to R, then your center will be plus minus R, comma plus minus R. Because according to the position of the circle, whether it is in the first, second, third or fourth, we will take the center accordingly. Getting my point? But in all these cases, for the third one, your mod G and mod F, they are always same, which is equals to R. That is the radius of the circle. Is it clear? So these three things we have to remember. When the circle is touching the x-axis, your radius will be mod F. When the circle is touching the y-axis, your radius is mod G. And when the circle is touching both the axes, in that case, your mod G, mod F will be same as your R, and the center is plus minus R, comma plus minus R, according to the position of the circle. If it is in the first quadrant, we will choose the center accordingly. If it is in the second, third, and fourth quadrant. Is it clear to all? Absolutely. Okay. So now let me take some problems based on that. Let us start with this first problem. The question is, find the equation of the circle touching the coordinate axis. Touching the coordinate axis. Axis. At a distance of 2 units from the origin. At a distance of 2 units from the origin. So let me just draw the diagram. So this is my circle. This is the coordinate axis. Now, the circle will be, it is touching both the coordinate axis. It is touching both the coordinate axis. Just 1 second. It is touching both the coordinate axes. So it will be something like this, okay? And what they have said is that it is touching at a distance of 2 units from the origin. That is, this distance is 2 units. Okay, I have taken this circle in the first quadrant. It can be in the second, third, or fourth quadrant also. So your center will be what? When it is touching both the axes and the distance from the origin to the point of contact with the x-axis is 2, it is given in the question. So your center will be nothing but 2, 2. Am I correct? Your center will be nothing but 2, 2, and the radius will be 2 only. Your radius is 2 and center will be, as it can be in the first, second, third, or fourth quadrant, so we can write the center will be at plus minus 2, plus minus 2. Therefore, what will be the equation of the circle? It will be x. I'm simply using center radius form. Plus y plus minus 2 whole square is your 2 square. Therefore, the equation of the circle will be equals to 4. So, how many such circles are possible which are touching both the axis and at a distance of 2 units from the origin? Such circles will be 4. 4 circles are there which will fulfill the given condition in the question. Is it clear? Therefore, our equation is x plus 2 whole square plus y plus minus 2 whole square equals to 2 square. Is it clear to all? Okay. Let us move further. These questions I have selected only because to understand the theory properly. These are pretty simple sums, but these sums will help us to know the theory better. See this question. Find the equation of the circle which touches the positive y-axis. Let me draw the diagram first. Find the equation of the circle which touches the positive y-axis. Okay, positive y-axis. So it is touching the positive y-axis. Okay, fine. So it is touching the positive y-axis at a distance of 4 units from the origin. That is, this distance is 4. This distance is 4. Okay? Okay. So this distance is 4 from the origin and makes an intercept of 6 units. Oh, acha. And makes an intercept of length 6 on the x-axis. It makes an intercept of 6 in the x-axis. Okay, so this distance is not your 4. The distance will be this one. So this distance are 4. Just 1 second. So this distance is 4. And this length is 6. Is it clear? Is this clear to all? Now we have to find out the equation of the circle. So what to do? See, what will be the center? Because one thing you all must remember, that for every time, as I told you many times, that for a circle, we are only concerned about 2 things. Its center, its radius. That's it. So what I will do, let us say this is the center. The center is, let us say, alpha, beta. Is it clear? Now, can you please tell me what is your beta? Here your beta will be nothing but 4. Why? Because this length is 4 which is given to us. Is it clear? This length is 4 which is given to us. Now from the center, so what will be the center? The center is basically The center is basically lambda comma 4. Yes, it is lambda comma 4. Okay. Now, from the center, if we draw a perpendicular on the x-axis, it will definitely bisect the chord. This we all know. So this length is basically what? 3. Now let me join this point with the center. Let me join this point with the center. This is what? This is my radius. But I don't know the radius. Let us say this length is r. Now, if this length is r, from this triangle, from this right angle triangle, we can say that r square equals to 3 square plus 4 square. It means what? Your r is coming to root over of 25, which gives us 5. That is, the radius of this, okay, which this question meaning, see, the question is, find the equation of the circle which touches the positive y-axis at a distance of 4 units from the origin. A circle is touching the y-axis at a distance of 4 units from the origin. Okay, so this length is basically 4. And they have said that it makes an intercept of length 6 on the x-axis. That is, this length is 6. This length is 6. Okay. So from here we got the radius r as 5. Clear? Means this is also the radius. This length is 5. Then can you please tell me what will be its center in that case? Your center alpha means this distance which is same as your 5. Therefore, your center becomes what? Your center becomes 5, 4. Is this conception clear to all? Is this conception clear to all? Since the radius is 5 units, that is, this distance is 5. So the center will be, this is 5, this length is 5, and this length is 4. So the center is 5, 4. Okay. Now, this circle, the condition that they have given, it can take 2 places. Either it is in the first quadrant or it can be in the second quadrant. It cannot be in the third or fourth quadrant. Otherwise, this positive y, when the circle touches the positive y-axis, it will not happen. If it is in the third or fourth quadrant, the circle is going to touch the y-axis in the negative direction. Therefore, we will not consider the circle in the third or fourth quadrant. Therefore, your center, as the circle can be either in the first or in the second quadrant, therefore its center will be plus minus 5, 4. Either it is in the first quadrant. When it is in the first quadrant, the center is 5, 4. When it is in the second quadrant, the center will be minus 5, 4. Thus, the equation of the circle will become, again, the radius, center radius form I am doing, plus y square, sorry, y minus 4. So y minus 4 square, which is equals to the radius, and the radius here is 5, which is 5 square. So what is the equation? X square plus minus 10x plus 25. I'm simply opening the brackets. This goes off. So it is x square plus y square plus minus 10x minus 8y plus 16 equals to 0. That's it. So that will be the equation of the circle. Why plus minus sign is coming? Because there are 2 such possible circles, either in the first quadrant or in the second quadrant. It cannot be in the third or fourth quadrant. The reason I have already explained. Okay, so our answer is this. So I hope you have all understood. If you have not, please do write in the comment section so that I can get back to you. Okay, let us move for the next problem. See this question. The question says, find the locus of the center of a circle touching the x-axis and passing through the point 4,6. Touching the x-axis. Okay. Let me just draw the circle first. It is touching the x-axis. So the circle will be something like this. It is touching the x-axis. Fine. Then, and passing through the point 4,6. So there is a point 4,6. The circle is passing through this point. So find out the locus of the center of the circle. So we have to find out the locus of this point. Let us say the locus of this point be h comma k. Is it clear? Let h comma k be any point on the locus. Is it clear? Let h comma k be any point on the locus. And we are finding out the locus of the center of this circle, which is touching the x-axis. Now, see, if a circle is touching the x-axis, what will be its radius? From the center, if I join the point of contact, this is called point of contact. What do you mean by point of contact? The circle, if we are having a tangent to a particular point on the circle, we call that point as a point of contact. So if we join this point to this point, the center, so this length is basically k, and which is nothing but the radius of the circle. Radius of the circle, which is your k. Or we can remember in this way also, we know that when a circle is touching the x-axis, the radius is always mod of f. Is it clear? So in this case, your radius is nothing but k. So we got radius as k? Yes. Now I have to find out the locus of the center. It means I have to find out a relation which will contain h, k and any other constants, right? So how to find out that condition? What I will do, I will simply join the center with this point, right? Now, if you join the center with this point, what is its distance? Its distance is, okay? And this distance is nothing but its radius. This is nothing but its radius, which is nothing but k. So if I open the bracket, if I square both sides, squaring both sides, so this is a relation which contains your h, k and constant. So this is the equation of the locus. So what is the equation of the locus? It is x minus 4 whole square, y minus 6 whole square is your y square. So simply open the brackets. Y square goes off. So we are left with x square minus 8x minus 12y 52 equals to 0. That's it. So this is the equation. This is the equation of the required locus of the center of the circle. Is it clear to all? Absolutely. Okay. So let us move for the next problem. See this question. The question states, that a circle is drawn to cut a chord of length 2a units along the x-axis and to touch the y-axis. Simple sum. So again, find the locus of the center. Let me just draw the diagram first. So what is happening? A circle is drawn to cut the chord of length 2a units along x-axis and touch the y-axis. That is, your circle will look something like this. Is it clear? Now you have to find out the locus of its center. This length is 2a. Okay? So let me do one thing. From this center, let me draw a perpendicular on the x-axis. If I draw a perpendicular on the x-axis, what will happen? What will happen? It is going to bisect the base. That is, this length will be your A, this length will be also your A. Is it clear? Now, let me join this point with the center. Right? So what will be its radius? What will be its radius? Let us say the radius be R. The radius be R. Okay? So if the radius is R, what will be this length? This is also the radius of the circle. So this is also your R. Yes or no? Tell me yes or no. Okay? So, how to find out the equation of the locus? But if I take R, I have to find out the locus of the center. So let me take H comma K be any point on the locus. Let me take H comma K be any point on the locus. Then we cannot take this thing as R. Okay. Why I'm telling you? Because as we have taken HKB and this length is H. And if this length is H, means this length is also H. Right? And this is nothing but the radius of the circle. Therefore, radius of the circle is nothing but H. Okay? And this perpendicular distance is K. So I have to find out the locus of this center. So I have to find out a relation which contains HK and the constant. In the constant in this case is A, which is given in the question. So by taking this right angle triangle, I am applying Pythagoras theorem. So we can say K square plus A square is nothing but H square. Yes. So we are getting H square minus K square is equals to A square. Therefore, the equation of the locus is what? X square minus Y square equals to A square. That's it. As simple as that. Hence, option B is correct. Is it clear? Is this clear to all? Simple thing. Always, whenever it is intersecting the x-axis, you always draw a perpendicular from the center on the x-axis, and it will bisect the intercepted portion. Apply the Pythagoras theorem to solve it. As simple as that. And always remember that if it is touching the y-axis, then, and it is intersecting the x-axis, so in that case, the center will be, if this distance is h, then the center will be h comma k. K is the length where it is intersecting, it is touching the y-axis. K is the distance from the origin where it is, the circle is touching the y-axis. Simply apply this and get your answer. Okay? Chalo. So let us move for another problem. See this question, which came in JEE Mains 2022. It has been said that if the circle is given x square plus y square, the circle is given okay, C belongs to any real value, passes through the point 6, 1. That is, this circle is passing through the point 6, 1, and its center lies on the line x minus 2c, y equals to 8. Your center is lying somewhere here on this line. Then the length of intercept made by the circle on the x-axis, that you have to find out. Let me draw the diagram first. Okay? And now the circle passes through the point 6, 1, it's okay, and its center lies on this line. Then the length of the intercepted made by the circle on the x-axis. Clear? Now the center, okay, even if I don't draw, I can do it. The center lies on this. First of all, what is the center of this circle? What is the center of this circle? It is G, comma, minus 3. Okay, this is the center. And they have said that this center is lying on this line. The center is lying on this line. Hence, it must satisfy this equation. So, G 6C equals to 8. This is the first equation that we got. Is it clear to all? This is the first equation we got. And they have already said that it is passing through the point. Which one? The circle is passing through the point 6, 1. Because you observe one thing, only two unknowns are there. One is G and another one is C. So I need two equations to solve for G and C. Is it clear? And then the moment we find that, we can easily find out the length of intercept made by the circle on the x-axis, because we all know that the intercept portion on the x-axis is basically 2 root over G square minus C. That's it. So we will simply apply that formula. So first of all, we have to find out G and C. One equation we got, we need another equation. And for that, they have said that this circle is passing to the point 6, 1. So let me just satisfy that. So we are getting what? It's 12G plus 19C equals to 43, right? So now we have to solve this equation and this equation to get the values of G and C. So let me multiply this equation with 12. So we are having 12G, 72C, 96. So let me subtract. So 72 minus 19, that will give us 53. C equals to 96 minus 43, that will give us minus 53. So we are having C as 1. We are getting C as 1, right? Now, what about G? If I put it here, we are going to have G equals to 8 minus 6C, which gives us 8 minus 6, that is 2. Okay, so G is nothing but 2. We got that. Now see, maximum students will do this mistake. Maximum students. That is why this question has been selected in JEE Mains. What student you will do, हड़बड़ी में क्या करेगा, वो देखेगा कि पहले मुझे C मिल गया and I got my G. Therefore, the intercepted length will be 2 root over G square minus C. So that will give us 2 root 3. And they will mark this. This is absolutely wrong. That will be absolutely wrong. Why it is absolutely wrong? Because we know that the intercepted on the x-axis is 2 root over G square minus C. But this C is basically coming from where? From this general equation of the circle. Look it carefully. What is C? Only C is there. But in our question, the C is not only C. It's minus 19C. Getting my point? So here our C is basically minus 19 of C. That you have to understand. If in the rush, if you write C as 1, you are going to get the wrong answer. This is absolutely wrong answer. So the answer will be 2 root over G square plus 19. That gives us 2 root 23. Getting my point? That will be your answer. The answer is not your B. So option D is correct. Try to understand the logic. That is why I told you that whenever you are memorizing any formula, know the form from where it is coming. Know the form from where it is coming. Otherwise, it will be difficult for us to solve it. We will solve it, but we will get a wrong answer. Okay. Here C is not, here C is actually from the, it is coming from the general form of the straight line. Circle. And that C is only C. But in our problem, the C is minus 19C. So we have to use that one only. Is it clear? Okay. So let us move for another problem. See this question. What is the question? A variable circle. A circle is a variable. Passes through a fixed point P, Q. You see, there can be lot of circles which are passing through a fixed point. The circle can be this. The circle can be this also because it is passing through this point. The circle can be this also because it is passing through this point, or say, let us say this point. So, see, this is that point through which infinite number of circles can pass. Infinite number of circles can pass, right? Now, they have given that this point, let me remove this. So, this is that circle which is passing to that fixed point. This is that circle which is passing to that fixed point P, Q. Okay. Now, it's a variable circle, as I just now I have shown you. Now, they have said, and is tangent to the x-axis, and it is tangent to the x-axis. That is, it is touching the x-axis. Okay. And this point, y, it has not been said where it is. So let us just assume this is my y-axis. Now, it is touching the x-axis. Okay, fine. Then what they have said? Prove that the point diametrically opposite to A, that is, the point which is diametrically opposite to A, that is, it is passing through the center. It is passing through the center, right? This is diametrically opposite end. Okay? So we have to show that this point, let us say this point be B, that this point is lying on this curve. That is, actually we have to find out the locus of point B. We have to find out the locus of point B. And we will show that the locus of point B is nothing but this one. Is it clear? That we will show. So let us say H comma K be any point on the locus. Okay. So what will be its center? Its center will be H plus P by 2, K plus Q by 2. Correct? That is, this, if I join this point with this point of contact, then this distance is nothing but K plus Q by 2, and which is nothing but our radius. Tell me yes or no. It's the radius. Okay. Now, what is the length of AB? It's root over. This is AB, which is nothing but our diameter. This is our diameter. So what will be the radius? The radius is half of AB. So which gives us half of root over H minus P square plus K minus Q square. Now by the problem, half root over, this is nothing but your radius, and radius is nothing but, the length of radius is nothing but K plus Q by 2. Is it clear? 2 goes off. Now square both sides. Now you see, this is an equation which contains H, K and the constants given. Here the constant is P and Q because that's a fixed point. So this will be the equation of the locus. Equation of the locus. Of locus of which point? Of the point B. Okay. So what is the equation of the locus? X minus P whole square equals to y plus Q whole square minus y minus Q whole square. So simply apply the formula a square minus b square. So you are getting a plus b, a minus b. So we are having x minus p whole square equals to 2y into 2q. So that gives us x minus p whole square is 4qy. Is it clear? So this is the equation of the locus. Locus of which point? Point B. What is point B? It is simply diametrically opposite to the point A. Hence proved. Is it clear now? Absolutely. Okay. So let us move for another problem. So this question came in JEE Advanced 2017. What is the question? For how many values of P? Now, IIT Advanced, they never used to give problems straight away. They will definitely give you problem mixed with something, or they will select problems in such a way that it will be the reverse of the conventional thing. It will be always the reverse of the conventional thing, like this. So far, whatever sums we have done, we are all dealing with this constant term of the general equation of a circle. Now they have said how many such P's are possible. Getting my point? That's your advance. So for how many values of P, the circle, this one, and the coordinate axis have exactly 3 common points. Exactly 3 common points. Now, what are the ways? What are the ways? Let me try to draw the figures first. The first option can be in this. The circle is intersecting the x-axis but touching the y-axis. One option can be this. Because in this case, we are getting that this circle whose center is at -1, -2, though I am taking it in the first quadrant, don't be confused with that, because -1, -2 is basically in the third quadrant. We are going to have the same thing over there. Only thing is that the coordinate of the center will get changed, nothing else. So I'm taking like this point to be -1, -2. Don't treat this thing as your first quadrant. I'm simply drawing a rough diagram to prove it. So now, in this case, when the circle is intersecting the x-axis at 2 points and it is touching the y-axis at only 1 point, this can be one case. Here, exactly there are 3 common points between the coordinate axis and the circle. Yes or no? Yes. What can be the other cases? What can be the other cases? The same thing can be done with the y-axis also. The same thing can be done with the y-axis also. Isn't it so? Now it is intersecting the y-axis at 2 points and touching the x-axis. In this case also, we are getting exactly 3 common points. Am I correct? Is there any other possibilities where the circle and the coordinate axis will have exactly 3 points, common points? Is there any other possibility? Please do comment me immediately. Is there any other possibilities? Yes, there is another possibility. What is that? When the circle, like this, when the circle is passing through the center and intersecting the x and y axis in this way. In this case also, if you observe, you will see that there are exactly 3 common points between the circle and the coordinate axis. So these are the 3 cases which are possible. Now again, jaldibaji mein answer mat likho ki your p will be equals to 3. No, because there are 3 cases. So there will be 3 different values of p. Therefore, your answer will be 3. No, because we have to check whether it is satisfying the given condition or not. That is very important. In this case, when it is intersecting the x-axis and touching the y-axis, in that case, what is the condition? The condition is g square minus c. Can you remember? G square minus c, it has to be greater than 0. And, not or, and f square minus c, it will be equals to 0. In this case, g square minus c is equals to 0 and f square minus c is greater than 0. And for the third case, your g square minus c is greater than 0. At the same time, your f square minus c, it will be also greater than 0 as it is intersecting the x as well as y axis. Clear? Now let us see whether this equation is satisfied, these conditions are satisfied or not in the given circle. In the circle we are having, I'm writing it here, in the circle we are having, this is at your center, where your G is basically 1, F is basically 2 and C is basically minus of P. Okay. So what is this condition? G square minus C is greater than 0. G square minus C is greater than 0. What does it say? It says 1 square plus P is greater than 0 implies your P is greater than minus 1. And F square minus C is equals to 0. It means 2 square minus of minus P equals to 0. That implies your P is equals to 4. I'm sorry, P equals to minus 4. P equals to minus 4. Yes or no? Yes or no? Because here we are getting P plus 4 equals to 0. So P is coming to minus 4. Is it clear? So this condition, both these conditions are to satisfy. But if you observe, you will find that as P should take a value more than minus 1, it is not going to satisfy minus 4. So this condition is not possible. Is it clear? Now let us check whether the second condition fulfills or not. So now you think, initially if you have written the total number of values of P will be 3, then you will be wrong. You can understand why it is so. Because it is not satisfying the first condition. That is why you should be very careful while solving JEE advanced questions. G square minus C is equals to 0. It means what? 1 minus of minus P equals to 0 implies your P equals to minus 1. And F square minus C is equals to greater than 0. It means what? F square is 4. C is this, greater than 0. So from here we are getting P is greater than minus 4. Is it satisfying this? Is it satisfying this? P is taking minus 1 and P should be greater than minus 4. Yes, it is satisfying. Therefore, we got one value of P as minus 1 for which the given condition in the question will satisfy. Right? Now let us check the third case. This and this. G square minus C is greater than 0. Now, look it carefully. So, it is 1 is greater than 0. That implies what? P is greater than minus 1. From the second one, what we are getting? F square minus C is greater than 0. That gives us P is greater than minus 4. Right? So P is greater than minus 1, P is greater than minus 4. So combining these two, we will say that P is greater than minus 1. Right? So now the question comes. People will be confused here also. Now he will say, sir, P is greater than minus 1. It means P can take infinite values. So is infinite number of circles are possible? That's the big question. P is greater than minus 1 means P can take infinite values, which are all more than minus 1. So does it mean that we are going to have infinite number of circles? No. You should be very careful about one thing. As the circle is passing through the origin, so origin must satisfy this equation. Not all values of P is going to satisfy this origin. So we are not going to have infinite number of values of P. No. So as your origin is satisfying this equation, so we are getting P equals to 0 only. We are going to get P equals to 0 only. That's the only thing that we are getting. And P equals to 0 is satisfying this condition. Hence, the second value of P that we are going to have is 0. So there are only two possible values of P. That is, for the given condition in the question, there are two such possible circles are there. Is it clear to all? Therefore, the required values of how many values of P? There will be two values of P which is going to satisfy our given case. Is it clear to all of you? Absolutely? Okay. Now let me take another problem, which is this one. What they have said? They have said that there are two circles in the first quadrant of radii R1 and R2 touch the coordinate axis. It is touching both the coordinate axis. Each of them cuts and intercepts of 2 units with the line x plus y equals to 2. Now you see, both these circles are doing the same thing. They are touching the coordinate axis, as well as it is cutting an intercepts of 2 units with the line x plus y equals to 2. So in this case, don't try to do the problem by taking both the circles. That will completely mess up. I mean, the solution will be messed up. So all you do is, you simply, as we can see that both the circles are doing the same thing, we will treat this thing as they are symmetric circles. So whenever you get some symmetric circles, you consider only one case, and automatically that 2 circles in our case will come. So don't worry about it. You only take one case and solve. You will definitely going to get 2 options for this one. Okay? So let me take the circle which is touching both the coordinate axis. Which are touching both the coordinate axis like this. Okay? And there is a line. There is a line which is our, let us say, x plus y equals to 2. Right? This is our x plus y equals to 2. Is it clear? So 2 circles are in the first quadrant. So naturally, I will take the center to be r comma r. Let us say we are taking the center as r comma r. That is, this length is r, right? Even if this is actually the radius of the circle, which is same as r. If I join this center with this point, this will be also equals to r, because as it is the radius of the circle. Yes, this is also r. Now let me draw a perpendicular from the center on this line. So what is the perpendicular length? Let me give a name. This is my A, this is B, let us say. So what is the length of AB? What is the perpendicular length drawn from r comma r on the line x plus y equals to 2? It will be this is our AB, which gives us, so we are basically having root 2 mod r minus 1. Is it clear? This is the length AB. Now let us set this point BC. Now in the triangle ABC, what you are getting? I am applying the Pythagoras theorem because this is your 90 degree. So if I use the Pythagoras theorem, what you will get? You are going to get AB square plus BC square equals to AC square. Now observe one thing. This distance, they have already given in the question that this distance is 2 units. So when we drop a perpendicular from the origin on this line, so your BC length will be 1. Okay, BC length will be 1. So AB square, which is your 2r minus 1 whole square, plus BC square is 1 square, and AC is nothing but the radius, which is your r square. Right? So now if we open the brackets, we are going to have, so it's 2r square minus 4r plus 3 minus r square is 0. Now, can you observe one thing? As I told you in the beginning of the question, that there is no need to do this sum by taking the the two circles. As their symmetry, you will do by taking only one circle, automatically two circles will come. You can see it from this quadratic equation. As this is a quadratic equation in R, so definitely you are going to have two values of R. That is, you are getting two such circles. You are getting two such circles. Is it clear? One on this side, and another one will be in the other side. Okay, this side. I cannot draw it right now because here there's a limitation of the space. So from here we are going to have the two roots as R1 plus R1 and R2. So from here we can write R1 plus R2 is 4, sum of the two roots, and product of the two roots is 3. Is it clear? So now we have to find out the value of this. So it's easy to solve. 2R1 R2 minus R1 R2. So we are basically getting R1 plus R2 whole square minus 3R1 R2. So simply put the values. So it's 4 square minus 3 into 3. So it's coming to 16 minus 9. That gives us 7. Is it clear? Therefore, the value of the given expression is nothing but 7. But have you understood this problem? The most important part of this problem is that whenever you find that symmetry is there, you don't consider all the figures and do. No, you only consider one figure, not only in circle, but throughout the whole conic section. If you find that the symmetry is there, you always take one figure and solve the problem. You are definitely going to get the other curves also. Okay, if you have 3 such curves, you will definitely get a cubic equation. If you have 2 curves, you are going to have a quadratic equation. So don't worry about it. That will come automatically. All you think is symmetric question, start with only one figure. That's it. Okay, so we have done a lot of sums. So let us just move for the next conception, which is your maximum and minimum distance of a point from a circle. Okay, there is a circle and we have to find out. There is a circle and we have to find out the maximum and minimum distance of a point from a circle. Now, the point with respect to the circle can be in 3 places. Either the point is inside the circle, or it is outside the circle, or it can be on the circle. These are the only 3 cases possible for this point to lie with respect to this given circle. Is it clear to all? Okay. So here I have considered 3 cases. The first case is that I have considered that the point P is inside the circle. Now we have to find out what is the maximum and minimum distance of this point from this circle. Now, directly from this figure, we can see, let me just delete all those. So we will get space to write. Okay. So now, for this first case, when the point is inside, what is the minimum distance? Tell me. The minimum distance is AP. And what is the maximum distance of point P from the circle? It is PB. Is it clear? Now, how to find AP? How to find AP in this case? Your AP is basically radius, or we can write this thing in this way. First, let us write in this way. We are finding out the distance AP. So we are doing in this way, CA minus PC. CA minus PC will give you AP. And PB will give you your PC plus PC plus CB. Is it clear? C is the center of this circle. Is this clear? So from the first one we can write CA is what? It is the radius. So radius minus PC is the minimum distance when the point P is inside the circle. And the maximum distance is PC, and CB is nothing but the radius, so it is PC plus the radius. Is it clear? So to find out the minimum value, you have to simply do radius minus PC. What is PC? P is the given point and C is the center of the circle. And for maximum value, you are simply doing PC plus CB, that is PC plus the radius. Right? This is when the point is inside the circle. Now, let us consider case 2, where the point P is outside the circle. If point P is outside the circle, what is the minimum distance of point P from the circle? It is again your AP, which is nothing but your, how to find AP? It is nothing but PC minus AC. That is PC minus AC is the radius. So it is the radius. And what is the maximum distance? Your maximum distance is PB. And what is PB? How you get that? It's PC plus CB. And what is your PC is there? What is CB? CB is the radius. So have you observed one thing in these two cases? Your maximum value of the point, whether it is inside or outside, the maximum distance we are always getting PC plus radius. C is the center and P is the given point. Okay, so that is the maximum distance. In both the cases, we got the same answer. Yes, for the minimum, it is different. We will come to the conclusion after the third case. What is our third case? First case, we have considered that the point P is inside the circle. Second case, we have considered point P is outside the circle. So now we are left with the third case where your point P is on the circle. So what is the minimum distance? Tell me, what is the minimum distance of point P from the circle? It is 0. Because point P is very much on the circle. So the minimum distance is 0. And what is its maximum distance? Its maximum distance is PC plus CB, which is your actually PB. That is the maximum distance. So which is nothing but, PB is nothing but PC plus CB is the radius. So it's the radius. Is it clear? So now the first conclusion that we are coming, that whenever we are finding out the maximum value, that is the maximum distance of point P with respect to the circle, it is always PC plus the radius. C, again I'm mentioning, C is the center. C is the center of the circle. And P is the given point. Okay, so maximum distance is PC plus its radius, irrespective of the position of P. whether it is outside or inside or on, because in the outside we got the same answer. In case of inside, when the point is inside the circle, we got the maximum value as same, PC plus radius. Yes or no? In the third case also we got PC plus radius. So maximum distance of the point from the circle is always PC plus radius. But for the minimum value, in this case it is coming to 0. And for the previous two cases, one is coming radius minus PC, and another one is coming PC minus radius. So can we combine all these three to write the minimum distance will be always PC minus radius? Modulus of PC minus radius. If it is inside, PC minus radius will give us negative value. Doesn't matter. We are always going, here we are getting PC minus radius. So either this value will be negative or positive. PC minus radius, in this case we are getting a negative value. No problem. The distance will be always positive. Getting my point? The distance, the minimum distance will be always positive. Whether it is radius minus PC or PC minus radius, doesn't matter. You have to take the modulus sign because distance cannot be negative. So whenever the question comes, a point is given and the circle is given, you have to find out the minimum and maximum distance. For minimum distance, you will always find out modulus of PC minus radius, irrespective of the position. Whether the point P is inside, outside, or on the circle, it doesn't matter to you. You are always going to have the value modulus of PC minus radius. And for the maximum value, I mean the maximum distance will be PC plus radius. It will be PC plus radius. Please do remember this too. Okay? So now let's move for a problem. See this question. The question is find the points on the circle, this. So there is a circle. There is a circle. And the center of the circle is where? Which is our C is nothing but 1, minus 2. Okay. And the point given minus 5, 6. Now, first question is, you don't need to find out, still I will find out, but here you don't need to find out the position of the circle. I mean the position of the point with respect to the circle. Because as we have seen there, for finding out the distance, you don't need to find out where the point P lies, outside, inside, or on, because our answer is irrespective of the position of point P. Okay, that is why I've generalized it. But sorry, in this case, we have to find out its position because we have to find out the points on the circle, right? So how to find out the position of this point with respect to this circle? All you simply do, in this circle, you put this point. In this expression, you simply put the point minus 5, 6. So if I put what we are going to have, 25 plus 36 plus 10 plus 24 minus 20. So I'm not calculating this. This is definitely greater than 0. Now, if this is greater than 0, it means the point is outside the circle. The point is outside the circle. Okay? Now, I have to find out. See the question very carefully. I have to find out, if I join this, now we can easily understand that if this is A and this is B, we can easily understand that our minimum length is PA and maximum length is PB. Yes or no? But we are not concerned about the We are not concerned about the distance because we have to find out the coordinates of A and B. We have to find out the coordinates of A and B. How to do it? Okay, let us do one thing. Let us find out what is my PC. PC is the distance between the point and the center of the circle. That is 516 square plus 8 square. So it is going to have 36 plus 64. That gives us root 100. That is 10, right? So the distance PC is 10. So this distance is how much? This distance is 10. Now, what is the radius of the circle? What is the radius of the circle? The radius of the circle is root over g square plus f square minus c. So we are having this is as 25. So that is 5. Is it clear? So radius is 5. So can you please tell me what is the minimum distance? Minimum distance PA. What I told you. Minimum distance is modulus of PC minus radius. So what is that distance? PC is your 10 minus 5. That gives us 5. So this distance is nothing but 5. And what is the maximum distance? Maximum distance is PB, which is nothing but PC plus radius. So that gives us PC is 10 and radius is 5. So that gives us 15. So this distance is 15. Okay, but we don't need this. What we need is basically the coordinates of point A and B. Now here we can find out the coordinates A in different ways. But the easiest way which I feel is that you can use parametric also. You can get the answer. But here we are getting that your PC is 10. That is given. We have seen that PC is 10. And the radius is 5. So this distance is also 5. And this PA, this distance is also 5. So I can say that A is which is the nearest point. That A is the midpoint of P and C. Therefore, the coordinate of A will be minus 5 plus 1 by 2. I'm using the midpoint formula. So we are getting minus 2, comma 2. Therefore, the nearest point A is nothing but minus 2, comma 2. Is it clear? Now, we know A, we know C. So we can easily find out what is the coordinate of B. Because again, C is the midpoint of AB as C is the center and AB is the diameter. So C is the center of AB. So this length is also 5. So now we can find out what is my B. How to find out that? We all know a shortcut form. Let me just tell you, because this you have to remember. If let us say this is alpha, this is beta, this is A, comma B. And we have to find out this coordinate. If this is the midpoint, always remember your x will be 2a minus alpha and y will be 2b minus beta. This is the shortcut way of remembering, of doing the sum quickly. Okay, otherwise you have to take this thing as xy and then apply the midpoint formula and solve for x and y. So I'm not doing that. I'm simply applying that formula. So your coordinates of B will be 2 times the center abscissa 2 minus alpha, that is, okay, comma, 2 times minus 2 minus 2. So your answer will be 2 plus 4 and this is minus 4 minus 2. So it is coming like 6 comma minus 6. Is it clear? Therefore, your coordinate B will be 6 comma minus 6. Right? Therefore, the nearest point is minus 2 comma 2. Nearest point is minus 2 comma 2. And the furthest point is 6 comma. Oh, why I'm getting 4? Have I done something? Yes. I'm doing a wrong thing here. There is a calculation mistake. This is actually 2 plus 2. Isn't it so? There's a silly mistake. So this is basically 4 comma minus 6, right? This is 4 comma minus 6. So the farthest point is what? 4 comma minus 6. Have you got the answer? Is it clear to you? So we can find out the nearest as well as we can find out the farthest point also. Before that, we have learned how to find out the minimum and maximum distance. Now we got how to find out the coordinates of that shortest and the farthest point with respect to the circle. Okay, so we have learned this. Now let us come to a new conception, which is our position of a point with respect to a circle. This we have already discussed. Suppose there is a circle. Now there is a point. Let us say the point is x1 comma y1. Okay. Now this point can be either outside the circle or on the circle or inside the circle. So how do you know that this point is whether outside, on or inside the circle? So for that, what I will do, in the given equation of the circle, the given equation is the general form, which is already written there. In that general form, you simply put, in this expression, you simply put this x1, y1, which I have denoted by s1. Throughout the coordinate geometry, I am going to use this notation. Please do remember, s1 means in the given curve, I have put the point. Now, if you find that your s1 is greater than 0, you will say the point x1, y1 is outside the circle. If it is equals to 0, you will say that this point is on the circle. And if it is less than 0, you will say this point is inside the circle. Is it clear? Okay. So please do remember this notation. S1 means in the given curve, I am putting the point given. That is your S1. Throughout your coordinate geometry, I will use this. I am doing circle. Here I am writing S1 as putting x1, y1 in the circle equation. When I will do parabola, I will use x1, y1. I will put x1, y1 in the given equation to get S1. So S1 is the notation I am going to use throughout your coordinate geometry. So please do remember what is S1. What is S1? Simply putting the point in the given curve. That's it. So now we have understood that how to find out the position of a point with respect to a circle. Okay. Now, let us take this problem. The question is, the circle, this one, this is given, does not touch or intersect the coordinate axis. Does not touch or intersect. Can you remember? For a circle, this, the center is minus g minus f. And when it is not touching or intersecting the coordinate axis, then your g square minus c is greater than 0 and f square minus c is greater than 0. These are the two conditions in which the circle is not going to touch nor intersect the coordinate axis. Okay, here your g is minus 3 and your f is minus 5 and your c is lambda. Am I correct? Okay. And they have said that the point 1, 4, it lies inside the circle. What do you mean by that? If I put this point, that is if we find out S1, what is our S1? 1, 16, minus 6, minus 40 plus lambda. This is your S1. Just 1 second. So since this point is inside the circle, so what we will write? We will write this is less than 0. So what you are getting basically? This is coming like 17 minus 6 is 11 minus 40 plus lambda is less than 0. So your lambda is less than 40 minus 11. That gives us 29, right? So lambda is less than 29. Lambda is less than 29. This is the first case we got. Now there are two other conditions. One is 9 minus lambda is greater than 0, implies lambda is less than 9. And from here, from the second one, we are getting your f square, that is 25 minus lambda. This is greater than 0. So that implies lambda is less than 25. Is it clear? Have I done everything correctly? Please check it. Lambda is less than 9. Lambda is less than 25. Lambda is less than 29. Is it clear? Please check this one. Please check it. Yes, I think I have done all correctly. Oh, I'm sorry. I'm sorry. Oh my God. I have done one major mistake. They are saying that it is not touching or intersecting the coordinate axis. That is, this is not your, I'm so sorry. This is actually, when it is not touching the x-axis, what will happen? What will be the condition? The condition will be, very sorry, g square minus c is less than 0 and f square minus c is less than 0. Can you remember that? Let me just refer to that slide. See this one. When it is not touching, when it is not intersecting or touching the x-axis, then your g square minus c is less than 0. And when it is not touching or intersecting the y-axis, f square minus c is less than 0. Right? So in this case, our condition is g square minus c is less than 0, f square minus c is less than 0. And, okay? So in this case, I'm very sorry. Really sorry. So in this case, what we are getting? 9 minus lambda is less than 0. And from here we are getting lambda is greater than 9. And from the second one, we are getting 25 minus lambda is less than 0, implies lambda is greater than 25. Okay? This and this, as well as and this. So we have to find out the common region. Your lambda is greater than 9, lambda is greater than 25, and lambda is less than 29. If we combine this, we will say that your lambda is greater than 25 and less than 29. And that is the range of lambda for which the given circle will neither touch nor intersect the coordinate axis, and the point 1, 4 is inside the circle. Is it right? Okay, now let us reveal the answer. Is it clear to all? Absolutely? Okay. So let me take another problem. Now see this question. Same question. The point, this is not your normal bracket. I have already mentioned here that this is the greatest integer function. So box of lambda plus 1, box of lambda. This point is lying inside the circle this. Then find the set of all values of lambda. Okay? Now, the point which is given to us can also be written as lambda, box of lambda, or greatest integer function lambda plus 1, comma, greatest integer function lambda. Can you remember this property? We all done in the basic mathematics. That is, greatest integer function of x plus any integer can be written as greatest integer function x plus the integer. So that's exactly what I have written here. Okay. Now, for a time being, let me take box of lambda is, let us say, a. Okay. Therefore, our point has been transformed into a plus 1 and a. And they have said that this point is lying inside this circle. Hence, it must satisfy. I mean, not satisfied. I will find out what is my S1. What is that S1 here? S1 is in place of X, I'm going to put A plus 1. And in place of Y, I'm going to put A. So what we are getting? So that gives us so we are having 2s square and we are having 2s square minus 16, right? So 2s square minus 16 as this I can write s square minus 8 as they have said that the point is inside the circle. Hence, your S1 will be definitely less than 0. Just now I have explained what I have explained. If S1 is less than 0, then what you say? The point is inside the circle. That's exactly what I have done here. S1, this is our S1. This S1 is inside the circle. Therefore, it has to be less than 0. It implies what? S square minus 8 is less than 0 implies what? S square is less than 8. So from here we can write your A is lying between 2 root 2 and minus 2 root 2. Can you remember this? If we have written x square is less than s square, that implies what? Your x is lying between, your x is lying between minus a and a. Okay? So that's exactly what I have done here. And what is your a? A is nothing but box of lambda. So box of lambda is lying between minus 2 root 2. Root 2 is 1.414 into 2 will give us minus 2.8 and this is less than 2.8. Now here it is box. So in this range, we have to find out what are the integers because box x is always an integer. So your box lambda can take the value minus 2, minus 1, 0, 1, yeah, 2. So when box of lambda is minus 2, your lambda is lying between minus 2, minus 1. When box lambda is minus 1, your lambda is lying between minus 1 and 0. When box lambda is equals to 0, your lambda is lying between 0 and 1. When box lambda is 2, your lambda is lying between, box lambda is 1, it is lying between 1 and 2. And when it is 2, your lambda is lying between 2 and 3. So from this, we can easily see that your lambda is lying between closed -2 till 3 open. Yes or no? Therefore, your option A is correct. It's a very nice question. This special function has been involved in this coordinate geometry. So in that way, it's a nice sum. Okay. Therefore, your option A is correct. Is it clear to all of you? If you have any doubt, please do write in the chat section so that I can explain it once again. Okay. Then let us move for the next part, which is called power of a point and length of tangent. These two things we will learn simultaneously. Simple thing, power of a point. It's a new thing that we have to remember. What is power of a point? Suppose a circle is given. I'm taking the general equation. This circle is given. And just now I taught you what is your S1. What is S1? Simply there is a point x1, y1. There is a point x1, y1. And now this S1 is basically putting this x1, y1 in this expression. So it is x1 square, y1 square, 2gx1 plus 2fy1 plus c. This is the expression. This is the value. And as we all know that if this is S1, I taught you, S1 is greater than 0. It means the point, which point? X1, Y1 is outside the circle. If it is equals to 0, inside the circle. And if it is less than 0, it is, equals to 0, it is on the circle. And less than 0, it is inside the circle. This I already taught you. Now, this S1 is what called your power of a point. Which point? In this case, x1, y1. That is why I was telling you repeatedly that this S1 is very important. S1 is basically called power of a point. So now onwards, I'm not going to tell you in this way that this point is outside, inside. No, I will say in this way that if the power of a point is greater than 0, the point lies outside. If the power of a point with respect to a point is equals to 0, the point is on the circle. And if the power of a point with respect to a circle is less than 0, then the point lies inside the circle. In this way, we will say. Is it clear? Absolutely. Okay, so S1 is nothing but, now onwards we will remember this S1 is nothing but power of a point. Power of a point. Power of a point not only valid for your circle, it is valid for parabola, ellipse, hyperbola, everywhere. So whenever we are saying that the point is whether outside, inside or on, we will talk with respect to power of a point. Every time I will say in that way. Whether this point is outside, I check the power of the point. If the power of the point is greater than 0, definitely it is outside. If it is equals to 0, definitely it is on the curve. And if it is less than 0, it is inside the curve. Okay, so please do remember this power of a point. So now we are going to do how to find out the length of a tangent. How to find the length of a tangent. Okay. So let me draw a tangent over here from a point outside the circle. Definitely the point cannot be inside the circle. Because if the point is inside the circle, you cannot draw a tangent. So this is the tangent and this is the center. Let us say this is the center C and this is the point A, which is x1 comma y1. And let us say the point where the tangent is touching the curve or the circle in this case is B, right? So now my task is to find out what is the length of AB. Very, very interesting. Very, very interesting. So how to find out this length AB? The equation of the circle is x square plus y square plus 2gx plus 2fy plus c equals to 0. Therefore, its center will be what? Minus g comma minus f. Right? Now, what I'm doing is I'm simply joining the point A with C and B with C. Okay? The moment I've joined this, you people all know that when I'm joining the point of contact with the center, B is the point of contact. This is what? Point of contact. What is point of contact? The point where the tangent is intersecting the curve. So now your CB is basically the radius, and which is nothing but root over of g square plus f square minus c. Yes. Now what is your AC? By using the distance formula, I can find out the distance AC, which is nothing but x1 plus g whole square, y1 plus f whole square. Okay. Now, since this is 90 degree, so I can apply the Pythagoras theorem. So here we can write that AB square plus BC square is basically AC square. AB, I need to find out that. What is BC? It is nothing but the radius square, which gives us, minus C. And what is AC? AC we got here, square of it gives us okay. So if we expand this, right? Now g square f square will get cancelled with this one. So AB square is coming to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Look it carefully. And root over of that. AB is what? It's root over x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Oh my God. What is this? What is this? This is nothing but the power of the point. So what is the length of the tangent? It is nothing but root over of power of a point, power of the point. Tell me yes or no. So AB is nothing but root over of S1. So interesting thing. So if there is a point outside the circle, and if we draw a tangent, then the length of the tangent will be nothing but root over of power of the point. Or you will remember in this way that the length of the tangent is root over of S1. That's it. Root over of S1. Simple. Is it clear? Is this clear to all of you? So we have learned power of a point. What is power of a point? Simply in the given expression or the equation given, put that point over there. That is the power of the point. And the length of tangent, indeed, it's no use of saying that it's point x1, y1 when you are finding out the length of the tangent. The point is outside the curve. Why? Because if it is on the curve, the length of the tangent will be 0. And if it is inside the curve, No tangents can be formed. So whenever you are finding out the length of the tangent, definitely the point is outside the circle in this case. So what is the length of the tangent? It is nothing but root over of S1. What is S1? Power of the point. As simple as that. Okay. So two things we have learned: power of the point and length of tangent. Please do remember. So now let us move for a problem. See this question. The question is, if the length of the tangent drawn from the point 5, 3 to the circle this. This is the given circle. And we are drawing a tangent to this circle from a point outside the circle. Now, in this case, you can ask me, sir, how do you know that the point is outside the circle? Yeah, at least trust the examiner who has given this question. Otherwise, they will never give you to find out the length of the tangent. Common sense. Because here you cannot find out now the point whether it is on, in, or outside the circle, because there is an unknown variable k. So you cannot find out the power of point whether it is less, greater, or equal to 0. So that is why I'm telling you, trust the examiner. So we have to find out the length of the tangent. The point is here. The point is outside the circle, which is your 5, 3. Okay. And they have said that the length of this tangent AB is 7. So find the value of k. Direct application of the length of tangent. So what I will do, I will simply put this point in the given equation, right? So what you are getting, 5 square, 3 square, 10, 3k plus 17. Yes. So this is what? This is the power of the point. So what is the length of the tangent? Root over of the power of the point, which is given to be 7. So what will be the answer? 25 plus 9 plus 10 plus 17 plus 3k is 49. Okay. So how much you are getting? This is your 35, 44, 44 goes that side. So 3k is 5 minus 17, right? So it's coming like minus 12. So k is coming like minus 4. Straight away. So option B is correct. Have you understood this? This is the simple application of finding out the length of the tangent. Okay. So length of the tangent is what? It is the square root. Again, I'm telling you, it is the square root of the power of the point. That's it. Okay. Chalo. Next problem. Let us come to this. Read the question carefully. If the length of the tangents drawn from the point 1, 2 to the circles, these two are different circles. These two are different circles. Be in the ratio 4:3. If the length of the tangents drawn from this point to the circles, this and this, be in the ratio 4:3, 7. 7 means the length of the tangent is 7. Okay. Then k equals to what? Then k will be equals to what? Simple sum. Length of the tangents drawn from the point 1, 2 is this, and this being the ratio 4:3 is 7. Okay. So what will be the value of k? Can you do this? Can you do this? This will be your homework. This sum will be your homework. You must try this sum before I start my second class. I will definitely do this sum and then I will start the next session of this class. Okay, but be very careful. One thing I'm telling you, please do observe the equation. जल्दीबाजी मत करो, धीरे धीरे. Okay, please try this sum. This will be your homework. Okay, so see you in my next class tomorrow. And you must try this sum before I start the next session. So we will be meeting tomorrow with the next session of this class. So stay tuned to us and don't forget to subscribe and like and share this video. Thank you. See you tomorrow.